All right, so one more result with sequences that we want to talk about, and this is a result known as the squeeze theorem. So the idea here is that you have two sequences, both converge to some value L. Okay. Then we have a third sequence, B sub n, that is trapped in between these other two sequences beyond a certain point. Now, initially, B sub n may not always be between the an for some early values, but past a certain value of n, it will always be trapped between. So B sub n can be as complicated and as bouncing around type sequence as you want. Right? It can be doing stuff where it's always rapidly switching in between two values a whole lot. So it can be doing, something, kind of a little crazy, like the example I've done here, where it's, kind of jagging, bouncing around a lot. But as long as it's trapped between these two, then we're able to conclude with confidence that the limit of the B sub n sequence must also be equal to L. Must also be equal to L. And so we can use this result, as we're going to do in the upcoming example, to establish a limit for something where we may not always be able to do it looking at it directly on its own. But if we can kind of trap it between two sequences, then we can still talk about the limit. And so the example I want to look at is the sequence that's defined by cosine n divided by n squared plus 1. Unfortunately, I can't talk about what happens to cosine as n goes to infinity, because cosine is a periodic function and it keeps just changing over and over and over again. Right? So that numerator just keeps changing values, and it doesn't settle in on a value. It's not like the example we had looked at earlier with the sine function, where it was sine of 5 over n in the example. Right? Now as n goes to infinity, 5 over n goes to 0. And so it is settling on to a particular value. But now here, this is just cosine of n. Right? And that doesn't settle into a single value. So it's very hard. How do we talk about the limit? Well, that's where the squeeze theorem comes in. Because I don't know what cosine n is for different values of n as n gets really large. We could compute them for a specific value, but what we do know is this, that the cosine of n is always stuck between -1 and 1. Okay. And so what that means is that cosine of n, that sequence, is always going to be trapped between the sequence -1 over n squared plus 1 and 1 over n squared plus 1. And we also know that as n goes to infinity, this goes to 0 and this goes to 0. So therefore we also know then that the limit as n goes to infinity of cosine n over n squared plus 1, that sequence is also going to go to 0. Okay, and so we're able to establish that with this squeeze theorem, because we're able to pen that function in between two functions, or two sequences really, but we can think of it as functions as well. We're able to pen it in between two functions that we actually can take the limit of. And so with that idea in mind, we're able to talk about what this sequence were. Again, we don't know. It's switching back and forth from positive to negative. But it's still going to zero. It's still going to zero.